Hi all, welcome back. So today we are going to solve one more question asked in the chemical engineering GATE exam. So this question relates to the instrumentation process control. I think this series is going to helpful to understand the concept through the questions. So let us start to solve this question. So I'm going through this reading out the questions. So the question they given the block diagram shown in figure. The transfer function g is equal to ky tau s plus 1. They are saying k greater than 0 and tau is also greater than 0. Alright. The maximum value of k below which the system remains stable. So based on block diagram, so they are asking the what is the maximum value for which system remains stable. It means all poles should lie in the left of the S plane. Okay, there is no repetitive pole in the j omega axis. All right. So for this, what's the approach to solve this question? So first, we need to find out the transfer function for this question, and for this system, we can say. So system nothing but this is like for this like a plant for which we going to design the controller. Okay, yeah, we are considering the we considering the plant actually for designing controller. All right. So here, so first we find out the transfer function. In this, we need to know the characteristic equation. This is nothing but this is like a polynomial of the denominator part. Okay. So and then we find out the other poles. If poles is right hand, sorry, left hand side, then we can say this is a stable. And thing is that in this question we are not need not to solve explicit pole location and position of the pole. Just apply the Rao-Hurwitz criteria. Okay, and then we can find out the whether the system is stable or not stable. Okay, so how we can find out the transfer function? Transfer function nothing but this is a ratio of Laplace transform of let down transfer function is a ratio of the Laplace transform of the output and Laplace transform of the input. Okay, provided that initial condition is all initial condition 0. All right. Okay, or we can say in real physical system is relaxed. Okay, there is no excited at all. Okay, so how we can find the transfer function? So here we need to simplify this. Let us say this is like a signal. We get x here. Okay, and here we applying this like this input we are putting here input like x, and this is transfer function g, and we find out the output y. So y is equal to x into g, the like series property. Okay, so parallel became summation actually. All right, so here this is only applicable for the we are not considering the loading effect. Okay, in upcoming video we will see what is the loading effect. All right, so this is a x. Okay, so if you find out this signal, let us say this is y, so y is equal to g into x, and finally this is a y this is how much value, let us say this is like z, so z is equal to y into g. All right, I think we need to change this variable because by they already given. All right, so here let us see, put here a. Okay, so this is our b, this is a. All right, because by they are considering the our output. So here what is the value of this actually, this is g into y, so we'll get the y into g. Okay, all right, then Here we get x actually. So x into g, will get the x into g. And this is our u means input reference we are feeding, and applying basically. So u into g. So finally we find out the by output. Let us say put in Laplace domain. So by s we can say like that. So xx into g. Yeah, simply no need to put like that, because in our gate exam time is less, so we can write like that also. So by, but correct way that we have to apply in Laplace domain. Okay, we have to write in Laplace domain, so capital letter we have to. Okay, so here by equal to x into g plus u into g, but I this x we need to replace here. Okay, so here because we need to find out the relation between the output and input. Output is by, input is u. All right, so here this is a x into g, but is a x here actually. Here x you can write here, this is a b, right? So b plus this is a by into g. What is a b here? B basically into uh, yes, b is equal to a into g into plus by into g. What is a actually? This is intermediate variables. We need to substitute in the our in terms of u. All right, u and by, because this is our relation we want to establish. So here a into g plus by into g. So what is a actually here? A is equal to g into x and g plus by into g. So we can say this is a g square x plus y into g. All right. So here let us say x is equal to 1 minus g. We have to left hand side y into g. So x is equal to y into g by 1 minus g square. Okay. So finally, let us put in our output equation. So this is my output equation. So here we have to replacing in x in terms of y. So this is by into g, okay, by 1 minus g square into g plus u into g. All right. So here, so by equal to by into g square by 1 minus g square plus u into g. So here let us consider all term in by in this side, left hand side. So u into g. So here by is equal to 1 minus g square, so it will be 1 minus 2g square by 1 minus g square equal to u into g. Okay, so by u equal to g into 1 minus g square by 1 minus 2g square. All right, so this is my transfer function. Here actually we can write like that, right? By s by us, because this all in a Laplace domain. All right. So what is our characteristic polynomial? Characteristic polynomial is numerator denominator polynomial. Okay. So characteristic polynomial is equal to 1 minus 2g square. Since if you want to write in a our what is a g actually here? G the given transfer function k by tau s plus 1. All right. So they given g is equal to k by tau s plus 1. So here they given in question k greater than 0 and tau also greater than 0. Okay, this condition very important. All right, so if you want to write down in a Cartesian equation also, so the polynomial should be 0. So we can say 1 minus 2g square equal to 0. All right, so let us put the g value. So 1 minus 2 into k by tau s plus 1. This is a whole square, right? Because this is a whole square. Okay, so this question relates to more calculative actually. Okay, so it we need to take care better way. So here, so 2k square by tau s square plus, I'm just expanding this formula. So tau 2 tau s into 1, okay, plus 1 square, a plus b square whole square. This formula we are expanding here, a square plus b square plus 2ab. All right, hope you understood, and equal to 0. So here let us again simplify. Tau square s square plus tau ts plus 1, okay, and minus 2k square equal to 0. We can write like that also. Okay, so this is my final characteristic equation. So in this we need to find out the poles, but in case of stability we need to find out these poles. Okay, we just apply the Raoult-Hurwitz criteria. First Raoult-Hurwitz condition is whether this given polynomial is Raoult-Hurwitz polynomial or not. For this, all coefficient of the this uh, term actually, okay, it should be same actually. I mean, this sign and this sign and this term should be same sign actually. So tau they given already in question, tau is greater than 0. Okay, and to tau of course when tau is greater than 0, then to tau also greater than 0. Then in order to apply the Raoult-Hurwitz criterion in further, I mean just tabulation, okay, create the tabulation. For this, all signs should be same. Okay, this is first condition we need to check actually. So this also greater than 0. I think this question no need to apply the Raoult-Hurwitz criteria. This condition is easy. We can get this. We can get solve this question actually. So 1 by 2k square greater than 0. So k, we can say 2k square less than 1. So k equal to 1 by 2 a square actually. Okay, so here k is equal to plus under root plus minus, right? But since under root when we apply, then but they are telling that k greater than 0, so minus 1 by root 2 we have to exclude. This will not applicable in this. So our answer will be maximum will be, because they are asking k maximum value, so k less than 1 by root 2. So this answer will be 0.707. If you 1 by root 2, if you solve it again, you will get 1.0.707. All right, so answer, I think this is they are asking the round of the two decimal places, so our answer is 0.707. You can round off to then 0.071, I think. Okay, this is also fine because they will give in some one range actually. All right, so what we understood from this question, actually they asking the stability, so just find out the transfer function for given block diagram. All right, and then we need to create the characteristic equation. Okay, because that's the main part to find out the our stability. Okay, whether a given system is stable or not. For this need not to find out the explicit poles location in S plane Just we need to ensure or apply the route base criterion. That's a very helpful, you know, need not to find out the explicit pole location. All right. So for this, first we apply the first condition. Okay, this is like we can say this is like a necessary condition. Okay, before going to form the tabulation, route tabulation. Okay, if you apply route tabulation also, still we can get same answer. Let us expand this question. But for this question, it need not to. It's not necessary actually. Okay, not required. So for this, how we can apply here? We need to first put in descending order. Okay, this power is 2, then 1, then 0. Constant term part. Okay, here we can say 0. Okay, then let us say apply here route criterion. So s square, s power 1, s 0, power 0. So what s is a square is a even order, even term actually. So this is a coefficient tau, and then 1 minus k square. Okay, then finally we'll get the tau s here, 2 tau coefficient, here we'll get 0. Then we will get 1 minus this is multiply here, and then multiply this divided by this term. Okay, so we'll get 1 minus 2k square. So our first column should be same sign. Okay, if sign gets changed, so in order to stable 1 minus 2k square, this should be less this should be greater than 0, because we know tau already given greater than 0. So in first column of the Rao Thurbe's cardinal table, it should be same sign. So this will be positive, then k, this is a minus 1. All right, so k less than 1 by root 2. Yeah, just be simplify in all, write down in all step. In question in exam you have to put all steps actually. So here is a greater than 0. Okay, so 2 square less than 1, k square 1 by 2, k is equal to under root 1 by root 2. So k equal to plus minus, but in question they given the k greater than, must be greater than 0. Okay, so that's why we are excluding the negative value actually. All right, so that's all for this question. Hope you understood.